question on formal proof. Whenever you've got something squared and you could have two quadratic equations and you're showing something greater than, what you're going to try always do is open out the quadratic bit, move all the values onto one side and complete the square. So let's go ahead and do that. So we've got x minus 5 squared minus 6x plus 50. So if we open that out, we get x squared minus 10x plus 25 minus 6x plus 50. That gives us x squared minus 16x plus 75. We complete the square for that. So remember, you half what's in front of the x. Then you minus it squared. That's 75. You can obviously check it on your calculator. If you put your calculator into polynomial, stick the equation in, keep pressing equals, so go past your x1, x2. It will give you the minimum point of x, which will be this 8, and the minimum point of y, which is 11. Okay, so we've got x minus 8 squared plus 11. Now, what do we know about that? So we know x minus 8 squared has to be greater than or equals number 0, as it's a square number. Therefore, x minus 8 squared plus 11 must be greater than 11. So we know that cos 2x has to be bigger than minus 1 but less than 1. So therefore 11 is always bigger than 1. So this is true. So we can say x minus 8 squared plus 11 is greater than cos 2x for all real values x. Right, so for the second part of this equation, or this question, sorry, you've got some information. And you've got to prove by exhaustion. So whenever you see exhaustion, you've got to try out all the possibilities. So if we take, and we're looking also at the product. So we've got product. So when we see the word product, we're thinking multiply. So we're thinking times. And we're going to say, what are we looking for? So we've got this weird notation. So the z plus means positive integers, so positive whole numbers, and y is all real numbers. Okay, so we've got x plus the modulus of y equals 6. Now remember, x has to be positive integers, so positive whole numbers. So let's think about this. We've got x and y. If x is 1, in order to add up to 6, y has to be 5, but because it's modulus, it could also be minus 5. And then when we multiply them together, 1 times 5 gives you 5, 1 times minus 5 gives you minus 5. If it was 2, this y would have to be plus or minus 4. 4 times 2 is 8. If it was 3, then it would have to be plus or minus 3, so we get plus or minus 9. If it was 4, plus or minus 2, again we get plus or minus 8. If it was 5, we're going to get plus or minus 1, so plus or minus 5. You've got to write out all these combinations. And if it was 6, we'd have 0 and 0. And that's it. We can't do any more because we've only got positive numbers that x can be. And then so we said all the products are between, if you notice, 10 and minus 10. And that's it. So when you're doing proofs, here's another set which you could... Okay, so here we're looking at a modulus of a linear function. If we're talking about a vertex of a linear, so meaning a straight line graph which has been modulus, so it's flipped upwards, what we can do is if we need to find that minimum point, so we're looking for this point P, we're going to take, almost treat it like complete the square. You look at what's inside the modulus sign, and that's the bit you're going to make equal to 0, and that's what's going to show you your x value for your minimum. So that's going to give me 3x equals minus a, so x equals minus a over 3. So here my x is minus a over 3, and my y is simply a. Okay, so that's my coordinates for point P. Then it tells us to sketch the graph g of x equals the modulus of x plus 5. So in order to sketch that, what we're going to do is, let's draw some axes in. We're going to say if I had y equals x plus 5a, when x equals 0, I can see y equals 5a. When y equals 0, x equals minus 5a. So x equals minus 5a. So I'm going to say 5a and minus 5a. I'm going to join them up, but I'm not going to go past down below the y-axis because I know modulus means everything is positive, and I'm going to bounce it back like that. Obviously you'll have more space and you'll draw it as a separate graph. And then it says these two graphs intersect at 2 points, and you want to find the coordinates where they intersect. Okay, so let's redraw our graph. What I'm going to do is actually draw it onto this one to show you what we are going to do. So we've got minus a over 3 and a. This one, when x equals 0, we're going to get modulus of a, which is a, plus a. So we know this is 2a. Now if I was to have 5a, it's going to be above it. And minus 5a is going to be over here somewhere in relation to this graph. Now, you can obviously draw in pencil or even draw in pen on your diagram. Now, if you notice, we're told in the question, it tells us that it meets at 2 points. So, what we can see is going to meet here, and it's probably going to meet somewhere up here, where this side of the graph meets. Now, if we think about it, x plus 5a is a positive graph. So it's talking about this bit here. The modulus, which is making the whole thing minus, would actually give you this bit of the graph, which isn't the bit that's intersecting. So all we care about is this bit here, right? Which is the original just x plus 5a. So we're going to say it's going to be when x plus 5a equals the original plus a, or when x plus 5a equals this bit which was in the modulus sign being negative plus a. Now if you didn't see it, you could consider all 4 options. So here we have gx positive, fx positive, gx positive, fx negative. We could consider gf negative, fx positive, and you would see that some of the answers just wouldn't work if you plugged it back in to both of them, if you can't see which bits you're using. So now if we solve this, put all the x's on one side, we're going to end up with 3x minus x, so 2x, 5a minus 2a, so that's 3a, so we've got, that's 2x, sorry, clearly I'm asleep today, so x equals 3 over 2a. Now if x is 3 over 2a, we can substitute that back in, so let's put it back into here. Doesn't matter which one, we should get the same answer. So 3 over 2a plus 5 is going to give you 13 over 2a. So then my coordinate here is 3 over 2a and 13 over 2a. And I can double check that, putting in f of x and showing that it works. Here I get x plus 5a equals minus 3x minus a plus a. These are going to cancel. So I'm going to get 4x equals minus 5a. And so x equals minus 5 over 4a. Do exactly the same thing, substitute it back in, and you get 15 over 4a. And those are your coordinates. Right, so I hope that helps. Okay, so we're going to be looking at function and function notation. So we're given a domain. A domain is your x values. So you've got your smallest x value of minus 2 and your largest one of 6. And here it's telling you it's equal to as well, which wouldn't otherwise be obvious. And now we want to write down the range. So you see the word range, you're going to think y values. But because we're in function world, instead of using y, we're going to use f of x. That just means a function of x. It's a fancy way of saying y. So what is your smallest y? It's 0. And your biggest y is 10. So we're bigger than or equal to 0, but less than or equal to 10. So now we're going to find f of 0, which essentially means we're going to find out if x is 0, what is y? And then whatever the answer is 0, what is the y? Okay, so if x is 0, we want to know what this coordinate is. Now logically, we can have a look at it and hopefully you can see some symmetry. We've got 2 and 2, so this would be 5. Now if you didn't see that, no problem at all. You've got 2 coordinates, you could find the equation of the line. So if we have a look, we've got 10 and 4, it's negative. So we've got minus 5 over 2, which would be my gradient. So we know we've got y minus y1, let's use this coordinate here, equals minus 5 over 2, x minus 2, which would give us y equals minus 5 over 2x plus 5, and you can see you found your plus c to be 5. Now, we want to find f of 5. So we want to know when x is 5, what is y? Again, you could look at the symmetry, or let's just take some coordinates. So first, if we have a look here, we can see from the question, 6, 4 is a coordinate, so that's going to be 4. And the bottom is also 4, so we know our gradient is x. And again, we're going to take that same y minus 0 equals, our gradient is just y equals x, so it's just 1, x minus 2. So we get y equals x minus 2. We're going to substitute our 5 in, so y equals 5 minus 2, which is 3. So f of 5 is 3. So the reason it's only 2 marks is because you could have seen it and could have subbed it in. But find your equations of the line, you'll find a little bit actually is useful for another bit of another part of the question. Okay, so part C, we're trying to find g to the minus 1. Now this is the inverse. So this is where we're swapping the x's and the y's. So if we rewrite this as y equals, now 5 plus 3x, 5 minus x. Now what I do is, because halfway through sometimes I get confused, am I finding x equals, am I finding y equals? If you've learnt it by changing the subject and making x the subject of the formula, by all means do it like that. At this point I swap all the x's and all the y's. The reason being is I don't want to confuse myself halfway through. Okay, we're going to multiply that up. So we're going to get 5x minus xy equals 4 plus 3y. We're going to put all the x's onto one side. All the y's onto one side and all the x's or anything that's not a y onto the other side. So I've got 5x minus 4 equals xy plus 3y. It's nicer to look at it like this because we want a y equals. So I'm going to take y outside the bracket and divide by x plus 3. Now, instead of it being y, this is actually g to the minus 1x. And so we found it. So now we want to solve g of fx equals 16. So g fx is going to be what? So what we're saying here is we want to put f into g. So it's always the second one into the first. And so wherever there's an x in g, we're replacing with f of x. So we get 4 plus 3 f of x equals 5 minus f of x, and that equals 16. If I multiply that up, I'm going to get 4 plus 3 f of x equals 5 times 16, so 80 minus 16 f of x. Move all my f of x's on one side, 19 f of x equals 76, so f of x equals 4. So I want to know when y is 4, what is x? Okay, we're already told here, when y is 4, x is 6. So my answer to this is simply going to be... Okay, so let's look at binomial expansion. So when we've got, so in this question, we can see that we have minus a half here. Now what that tells us is that n is not a natural number, it's not a counting number. So we have to use this formula over here. Now the problem is we have a 4 when we need it to be a 1. So we need to take 4 to the minus a half outside. And we're left with 1 minus 5 over 4x to the minus a half. And what we're going to now do is we know 4 to the minus a half is 1 over root 4, so a half. And we're going till x squared. So we have our 1. We treat, wherever we see an x, we're going to put minus 5 over 4x. And wherever there's an n, we put minus a half. So we end up getting 1 plus minus a half, which is your n, times your x, which is minus 5 over 4x, plus n, which is minus a half, n minus 1, which will give you minus 3 over 2, over 1 times 2, and then minus 5 over 4x all squared. And you want to go up to the x squared term. When we open all of that out, so we've got a half times 1, which is a half, and in your calculator you can literally do a half times minus a half times minus 5 over 4, which is going to give you plus 5 over 16x. And then minus a half times minus 3 over 2, and the important thing is it's all of this squared over 2 and then times by a half as well. And you get 75 over 256 x squared. So that's the first bit. And then now we're given 2 plus kx over, and we recognise that this is the same as all of this. Okay. And we've got to think about what happens. So essentially, f of x here is 2 plus kx. Sorry, so 2 plus kx multiplied by 4 minus 5x, the minus a half. Because if we bring that up, it's going to be equivalent. So the one on the bottom is to the power of a half, but if we were to bring it up, it becomes minus a half. So we want to multiply this that we've got here by 2 plus kx. So we can start off by doing that. So we've got 2 plus kx multiplied by a half plus 5 over 16x plus 75 over 256 x squared. And what we're trying to do is we get told that we have 1 is still 1, but the x term is 3/10. Okay, so how are we going to get an x term? The x term is going to come from that times that plus that times that. So if we compare our x terms, we've got 2 times 5/16, so 10/16, plus a half k equals 3/10. So therefore k is going to equal minus 13 over 20. So that's part B. And then part C asks you to find m, which is the x squared terms. So like, how do we get x squared? X squared is going to be x times x, so we need this one, and 2, which is nothing, times that. So we end up with 2 times 75 over 256 plus 5 over 16 times your k, which was minus 13 over 20, and all together, stick that all in your calculator in one go. It gives you 49 over 128. So m equals 49 over 128. Don't be scared if you get weird numbers in the exam. It does happen. Hope that's you. Okay, so here we've got an iterative formula. We want to write the expression we have here in this form. And the thing that's going to give us the clue is the cube root. So we want to make 2x cubed the subject of the formula. So equals 0. We're going to move everything over to the other side. That's not 2x cubed. So we get 20 minus x. We notice, and it equals 0 because it says there, sorry. And we notice that it's just x on its own. So we've got to divide by 2. So we get 10 minus a half x. And then we want to take the cube root. And when we take the cube root, we've got something in the expression in how we want to see it. Okay, so that's 10 minus, so if that's not clear, I've got x equals the cube root of 10 minus a half x. Okay, so now what I want to do is, if I didn't see that, what could I have done? So if you hadn't seen that, what you could have done is gone backwards. You could have cubed it, moved everything to one side, plus bx minus a equals 0, and then worked out how that connects to your fx. So that's another way to do it. Now they've asked us to start with x equals 2.1 and plug it into this formula. So in this formula, let's make that look a little bit nicer. So in this formula that we have, we can see that we're going to use this 2.1 as our first one. So in our calculators, 2.1 equals, it's now stored as your answer. Then you're going to do the cube root of 10 minus a half times answer. And then you can just hit equals as many times as you need to. And in this case, we want 2 more. So that's part B. For part C, we want to use a suitable interval and show that 2.077 is a root. So if we take 2.077 and we got the top end and we got the bottom end. Right, now in case you're concerned with how you get the 2 bits that you're going to look at, is you take whatever value you've got here and you add a 5 on the end. And that's always going to be your upper bound. And then take the last 2 numbers and take away 10, and that's what your lower bound is going to end with. So now the important thing is to remember is you're putting it back into the original. You're not putting it into the iterative form. So you're doing f of 2.0765, which is going to give you minus 0.016, which is less than 0. And if we put it into the other end, I get 0.001, so greater than 0. And then I have to write a sentence. I have to write, as there is a change in sign, so change in sign, and the function is continuous, and then you can write the formula. Then you can write, sorry, not the formula, what it says in the question. We say 2.077 is a root of the equation fx equals 0 to 3dp. So you rewrite the formula. That blurb has to be written for you to get the marks. So be really careful there. And now it's saying, what state any root of this equation? So now if you look at the connection, instead of x in the cubed bit, we've got x plus 2. So actually what we've got here is f x plus 2. We can double check that. So if we put that in, x plus 2 cubed, that agrees. Instead of x, we're going to have x plus 2 minus 20 is going to give us 2 minus 20, which is minus 18. So that makes sense. Now remember, inside the bracket affects the x's. The x's are like your ex-friend, girlfriend, boyfriend, you know, whatever. They do the wrong thing. So if it says plus 2, what's happening to the coordinate? It's moving minus 2. So instead of one of your roots, which we found to be 2.077, we are going to minus 2, and our root would be 0.077. Okay, I hope that's useful, and yeah, we'll get on to the next question. Okay, I've noticed a mistake here, and I apologise for anybody that had tried to do this question. Originally, this was supposed to be changed. So it was cos theta, it should be tan theta. So if you've tried this question from the classroom and not got anywhere, that's why this is what it should look like. Okay, so let's work through it. We know we've got a geometric sequence. So the first term we usually call A, and then the next term we take that first term and we multiply it by something. So we call that R to be the ratio. And the third term will be the second term multiplied by that R again. So the connection between them is the second one divided by the first one is the same as the third one divided by the second one. Because in both cases, you've got AR over A, you were left with R, AR squared over AR, you're left with R. So let's solve this. We're going to multiply that up. That gives us tan squared theta equals 0.9 sec theta. And tan squared, we know that 1 plus tan squared from our identities equals sec squared. So we know that to be the case. So now what we're going to do is we want tan squared, which is sec squared theta minus 1. That's 0.9 sec theta. We want to make it look like that. We know that 0.9 is the same as, and we could rewrite it as 9 over 10. And then we can multiply everything by 10. And when we do that, we get 10 sec squared theta minus 10 equals 9 sec theta. Move everything onto one side, and you've got the solution. Now you just use your calculator. So in your calculator, go to your polynomial, and you're literally just going to type in the coefficients. So 10 minus 9 minus 10. And you will end up with sec theta equals, you don't need to show workings for this step, 1.5466. Or you're going to have sec theta equals minus 0.6466. Now we know sec theta is the same as 1 over cos theta. So we've got to do 1 over our answers to get what we need. So if we go 1 divided by 1.5466, we get 0.64. Let's make that 7. Now for minus 0.6466, if we do 1 over cos, we're going to get a number larger than 1, which is, we don't want that. When you divide by a fraction, you're going to get a large number on top. So you're just going to put not valid. And then you do inverse cos of 0.647, and we get 49.684. If we have a look, we want it in that interval. So to 1 decimal place, that's 49.7 degrees. Now we want to prove that it's convergent. So we've done part A. We're now going to do, we've done part B as well because we found the interval, and now we're going to do part C. To prove that, we want to find the R. Now we know that R is either that or that. It's probably easier to put the right hand side in. So 0.9 over tan 49.7. And so 0.9 divided by tan 49.7. And I get 0.7632. And we know that this number is less than 1 and greater than minus 1. You probably do that as a separate line. Therefore convergent. Okay. Now for part D, you're just sticking into it this formula, which you're given in the formula book. So we know that A is sec theta. So we can do 1 divided by cos 49.7, which gives me 1.546 divided by 1 minus my R, 32. And when I do that, I get, so 1 minus 0.7632, I get 6.6 divided by 1 minus 0.7632. Sorry, I'm doing it at the same time. So you get 6.528 dot 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 to two significant figures. That'd be 6.5, and that would be your sum to infinity. Hope that's useful, and apologies for the mistake on this question. Okay, so step 1 of this question is really straightforward. What it's asking you to do, it's asking you to express 2 sine theta plus cos theta in the form r sine theta plus alpha. You're given this in your formula book. You're going to do some matching. So your theta matches up with A and your alpha matches up with B. But the whole thing is multiplied by r, so we're going to put r on the outside. So we've got r sine theta cos alpha plus r cos theta sine alpha. And we know that the 2 sine theta is going to go underneath here. And instead of cos theta, we're going to write 1 cos theta. It's going to become, just so we realise there's a coefficient. We do some matching. We can see in front of the sine theta, we've got a 2. And in front of, so what's left then is an r cos alpha. So 2 must be the same as r cos alpha. In the same way, r sine alpha equals 1, divided by r cos alpha equals 2, gives you tan alpha equals 1/2, which when you do shift tan of 1/2, you're going to get, let's see what they want it to, 2 decimal places. So you're going to get 26.57. And that's perfect because it's in your range 0 to 90. We don't need to do anything with that. Our r is always Pythagoras of the coefficients. So you get 2 squared plus 1 squared, so root 5. And then you sub it back in. So root 5 sine theta plus 26.57. Okay, in the next question, we've got a weird diagram, but you're not going to stress about it. Let's just have a look at it. We've got design for a logo. It's only 2 marks. This can't be that difficult. We've been given an angle, and we're told they're 4 meters apart. So if I can find this length and this length, I know it adds up to 4. Now, if I take this triangle here, let me redraw that. So I take this triangle over here. I know the hypotenuse, and I want the opposite. So I know that sine theta equals opposite over hypotenuse. The opposite must be 4 sine theta, because I rearrange it and bring the 4 up. So this is 4 sine theta, and that's because it's opposite the angle. Now, if I think about what the angles will be up there, well, I've got thetas here because of the z angle, or alternate angle. This will be 90 minus theta, right? Which means, because that's 90, as we have a rectangle, what we're going to have up on that first diagram is you can instantly see if that's 90, then this bit here, actually if we chop it like that, that's 90, that bit here has to be theta. That's probably an easier way to say it. Or I can simply say, because that's 90 minus theta, that's 90 degrees, that's theta. That makes more sense, doesn't it? And we know that this is adjacent, so it's next to it. So here I'm going to end up with 2 cos theta. Right, once we have those, we can make them equal to 4. So 4 sine theta plus 2 cos theta equals 4. Divide everything by 2. 2 sine theta plus cos theta equals 2. And then we need to, well, we've done part B. Part C is solving the equation. So when we solve it, we write the equation and we're making this one equivalent to 2. Divide by root 5. And then I've done shift sine of root 5 and I get an answer. And because we're in sine world, the next solution is always 180 minus x. So I get 116.56. And then if I minus 26.57, the only one that's available for me to go is the earlier one. Right, part D. Rectangles C and D are triangles that touch for a distance of h meters. Okay, fair enough. Find the value of h, giving your answers to two significant figures. Right, so we know that's h. We know that this side is 2 centimeters. And we probably need to, I guess we're trying to share things semi-usefully because it'll make his days a lot easier. So fingers crossed. So this section of the AS, which you would have done at the end of AS, is the bit that's tested the most, if you like, when you get to your when you get to these exams. So we've got a graph P equals AB to the T, and we've been told a straight line's been drawn of log 10p against T. So we're going to log 10 both sides. And when we do that, on the right hand side, we use the log rules and we separate this out. But we know also that T can come down. So as part of your log rules. And then we're going to compare it to y equals mx plus c. In this question, we've got log 10p, which matches up to your y, if you like. You've got t, which is your x, and connected to it is log 10b. So your gradient, which is your m, must equal log 10b. So that's 0.09. And then by the same way, your plus c is going to be your intercept, is going to be the same as your log 10a. So that's 0.68. And then to open this out, we just do 10 to the power of 0.09 equals 10 to the power of that equals. So we get b equals 1.23 and a equals 4.79 to 2 decimal places. Okay, so the next bit asked in context of the model. Now the model is about a population who have access to the internet. So the constant happens when t is 0 because b to the 0 equals 1. So when t is 0, the population equals that a. So what does that mean? It means the population, so the is going to be with access to the internet. And it's going to be initially, but what is the initial here? The initial here is the start of 2005. Access to the internet at the start of 2005. And then part C says, use the model to estimate the percentage of the population who had at the start of 2015. So that's in 10 years time. So we said A was 4.79 times b to the t, so it'd be 1.23 to the power of 10. And we're estimating, so the population, so it's the percentage of population. That's what the question's about. And it equals, and I get 38. So that's how you would do that question. Okay, so this bit here isn't really part of the questions. It's more because the sample information said the graph of y equals a to the x, which is any value to the power of x, which is going to give you this exponential graph. I just thought I'd do a few bits on drawing those graphs and changing them. However, I think because a lot of people have the graphical calculators, it's less likely that you'll have to sketch them with actual numbers in. It might be like sketch the graph of y equals, x plus k, where k is positive. So you could have y equals 2 to the power of x plus k, and they tell you k is bigger than 0. So you'd say, okay, if x is 0, then y is 2 to the k, because that's where it goes through. And I'm just literally shifting the x's, so I won't really be able to tell from my diagram how this is different, but it's going to have shifted a little bit. So let's make sure that lines up. And so you don't need to worry too much, but just in case, just have a look and make sure you've revised these graphs. Okay, so now we're going to differentiate implicitly. We've got 16y cubed, so we're going to bring that 3 down, so 16 times 3, and that's going to give us 48y squared, but because there's a y, we write dy dx, so that's how implicit works. The next one's a product, so we've got 9x squared, and we've got v equals y, so differentiating u is going to give us 18x, differentiating v is going to give us 1 dy dx, because there's a y there, and then we do those two and those two. So we get 9x squared dy dx plus 18xy minus 54 equals 0, and the 54 comes from the minus 54x. We take dy dx outside a bracket, and we've got 48y squared plus 9x squared equals 54. At the same time, we're moving the other stuff to the other side. So dy dx equals 54 minus 18xy over 48y squared plus 9x squared. Everything divides by 3, so we get, everything divides by 3, so we get 18 minus 6xy over 16y squared plus 3x squared, and that will be its simplest form. So that's part A. For part B, find the coordinates when dy dx equals 0. So what we're going to do when we make this equal to 0, the bottom is going to disappear. We essentially will be left with 18 minus 6xy equals 0. And you want to solve this simultaneously with the first equation. So you're going to rearrange it for either for x or for y. So I'm going to rearrange it for x. I get 6xy equals 18. So x is going to be 3 over y. And I'm going to sub it into the beginning equation. So I get 16y cubed plus 9 lots of 3 over y squared multiplied by y minus 54 3 over y equals 0. Now I'm going to let you clean that all up. If you have any problems doing so, let me know, but you should end up with 16y to the 4 plus 81 minus 162 equals 0. So 16y to the 4 equals 81. And so y to the 4 is 81 over 16. So to find y, we're going to take the square root and the square root again. So we take square root of 81, we get 9, root it again gives us 3. And the same at the bottom is going to give us 2. But remember, we have plus or minus. So we've got our two answers. We then need to sub it back in to find our x coordinate. So we can just put it into here. So if we have 3 divided by 3 over 2, we're left with 2. So now my coordinates are going to, well, let's put it in anyway. X equals 3 divided by 3 over 2, which we should know is 2. And the other x coordinate is 3 divided by minus 3 over 2, so we'd get minus 2. So hence our values are 2, 3 over 2, and minus 2, minus 3 over 2. Okay, so so we've got differentiation from first principles, whereas this beginning bit doesn't really have to do with that. We've got a curve and a line, and we're going to find out where they meet. So x to the 4 equals 8x. Move everything to the same side. We're going to take x outside the bracket, and we get x cubed minus 8. So x equals 0, which we can already see, and x cubed equals 8. So therefore we end up with x equals 2, so the cube root of 8. And y is going to be 2 to the power of 4, which is simply going to be 16. So my coordinates, so my part A here, is just going to be 2, 16. And if I want to find out the area bounded by the line and the curve, so what I'm going to have is the bit that's shaded. So I've got a triangle minus this area here, which is underneath the curve, between Q, or the coordinate at Q and O. So I am going to integrate x to the 4 between my x coordinate, which I got to be 2, and 0. So I get x to the 5 over 5 between 2 and 0, which is going to be 32 over 5. And I want to take that away from the triangle, which this length here is 2, and that's 16. So half of 2 is 1, 1 times 16 is 16, so I'm doing 16 minus 32 over 5. And so the area equals, and so we get 9.6 square units. Anyway, in part A it also said to show that the area is 16, we didn't do that, so we just kind of do a half times the base times the height. It's just going to be 16. Okay, the second part of this question, you were given that fx equals x to the power of 4. So it says to complete the identity. So essentially you're using binomial expansion to open this out. So we've got x plus h to the 4, which will be x to the 4 plus 4x cubed h plus 6x squared h squared, 4x h cubed plus h to the 4. And in the formula that we use to do that is from our binomial expansion, where we have a plus b to the n. Then we're told we've got fx plus h, and we're minusing fx divided by h. So now we're just doing it step by step, we're simplifying it. So if from this equation I minus x to the 4, that bit's going to cancel. I can also see I've got some like terms to put together. I've got 4x cubed. Oh no, I haven't any like terms to put together. Ignore me there. We have, instead, we're going to divide all of this now by h. So there's a h on the top and a h on the bottom. So that goes, that becomes q squared, and that becomes cubed, leaving me with 4x cubed plus 6x squared h plus 4x h squared plus h cubed. And we then say, as h goes towards 0, 6x squared h, 4x h squared and h cubed all tend to 0. Therefore, f dash x equals, if we see that we've cancelled everything out, we're left with 4x cubed. And the limit, if you want to, actually represents, yes, the gradient, but it's the gradient of the tangent to the curve. And that's what that represents. Okay, so this part of the question, when we're looking at Newton-Raphson method, is exactly the same as what you need to do when you do an intersection question, when you're finding a root in an interval. So you're going to do f of 1.4, so in your calculator, we've got 1.4 cubed minus 10 square root 1.4 minus 4 times 1.4 over 1.4 squared. You don't need to write this. This is just me showing you what you're doing, and you get minus 0.4356, so on. If we do f of 1.5, we get 0.598, okay? And we say this is less than 0, this is greater than 0, so there is a sign change, and fx is continuous, which is the important bit. So root alpha is an interval 1.4 to 1.5. Okay, so for part B, we want to differentiate it. Before we differentiate it, we're going to separate it out. So this is the same as 10x to the half over x squared, 4x over x squared, which is the same as x cubed minus 10x to the power of minus 3 over 2 plus 4x to the minus 1. And so now we can differentiate it. And when we differentiate it, we've got f dash x equals, that comes down, 3x squared minus, and minus make a plus, so plus 15x to the minus 5 over 2 minus 4x to the minus 2. Part C, we're going to use Newton-Raphson's method, which is in our formula book. So in your formula book, hopefully I've got a copy of it here, is given, if not I'll just write it out for you. So in your formula book you get given trig, numerical methods, yes we go. Under numerical methods you've got Newton-Raphson's, and as you can see there you've got your first xn plus 1, so let's rewrite it down here so we have it. Xn plus 1 equals x to the n minus f of x to the n over f dash of x to the n. And so we've been told our first term, because we've given our first term as 1.4. So we've got 1.4 minus f of 1.4, which we already did up here, which was minus 0.4356, divided by f dash of 1.4. So we're going to put 1.4 into this expression and I get 10.3 something. So you stick that in, 3072, and you end up with 1.442 to 3 decimal places. All right, so nice and straightforward. If you get Newton-Raphson's and because it says minimum and maximum, it's likely they just want you to differentiate it. And maybe that's what the fx is. I imagine there's going to be some differentiation first, making it equal 0, and then you need to determine it. Right. Okay, so now we're going to look at differentiating curves parametrically. Right, so we've got x equals 1 minus 8 cos 2t. So we're going to differentiate each of them separately. Now remember, with your trig, sine differentiates to cos, which differentiates to minus sine, which differentiates to minus cos, and if you want to integrate, you go round the circle the other way. If you have a value, so if you have any trig identity and something x, so for example with sine ax, when you differentiate that a comes in front and the sine in this case becomes a cos. So dx dt is going to give me 16 sine 2t, and dy dt is just going to give me 9 cos t. And if I want dy dx, I have to do dy dt multiplied by dt dx, which is the sine 2t flipped over. So essentially I put the one with the y on the top and the one with the x on the bottom. Right, so now we could we've got there, and now we want to know what happens when x equals 5, because we need a t value to substitute into there. So when x equals 5, we get 5 equals 1 minus 8 cos 2t. So that gives us cos 2t equals minus a half. We want to be in radians. Have a look at your range, your domain, or your values of t that you need. So inverse cos of minus a half is going to give you 2 pi by 3. So t is going to give you pi by 3. Now we substitute that in. When t equals pi by 3, dy, and when they're asking for an exact value, sometimes if you type it all into your calculator in one go, it doesn't necessarily give you the right answer. You probably need to do both bits separately, right? So on the top, you're going to get 9 over 2, and on the bottom, you're going to get 16, so you're going to get 16 times by root 3 over 2. So you're going to get you're going to get 8 root 3. Right? Which is going to leave you with 3 over 16 root 3. Now, you might have to do that, like I said, depending on how your calculator gives it to you, you might have to do that in bits, but your calculator should give you 3 root 3 over 16 or so on. So then you know your K is 3/16. Okay. The next bit of this question, use some more trig. It says, show that all points on C will satisfy y equals 9 over 4 root x plus 7. So let's remind ourselves we had x equals 1 minus 8 cos 2t and y equals 9 sine t. Whenever you have to find a Cartesian, what you have to do is make the trig identity bit, so the cos, the sine, the cos 2d, the subject of each formula. So we're going to rearrange this first one to be cos 2t is equal to 1 minus x over 8 and sine t is the same as y over 9. And then you say, what formula connects cos 2t with sine? And we know that cos 2t can be written in 3 ways. One of them is 1 minus 2 sine squared t. And we substitute in. So 1 minus x over 8 equals 1 minus 2 y over 9 squared. And so we want to make this y the subject of the formula. It's only 1 mark for all the manipulation, so don't spend too long playing with it. So we've got 1 minus x, so we'll have 1 minus x over 8 equals 1 minus 2, and this is going to give you y squared over 81. Okay, so we'll have this, so when we do that, we can then multiply up some stuff. So if I put the y's onto the left hand side, I'm going to have 2 over 81 y squared equals 1, if I split that up, minus 1 over 8 plus 1 over 8x. Right, they don't have any denominators, so we're going to multiply, I guess, everything by, we want to end up with 4 on the bottom. So if we multiply everything by 2, which should be all right there. Okay, I'm not sure what they've done. So if we do 1, okay, so if we do 1 take away 1 over 8, we've got 7 over 8 plus 1 over 8x, and so y squared will be all of that multiplied by 81 over 2. So you get y squared equals 7 over 8 times by 81 over 2, which is going to give you 567 over 16 plus 81 over 16x, and we want to take 9 out of 4 out, so that's actually taking 81 out of 16 out of the bracket, so because we're going to take the square root of it, which is going to leave us with, inside a bracket before we square root, x plus 7, and then we take the square root of that and we get the answer. It's a bit long and you'll probably be able to manipulate it quicker, but that's the marks are for recognizing the identity, substituted in, and then all the manipulation is only worth a mark. So if it's taking you a long time, just leave it. Okay, so that's part B. Part C says A and B are constants to find the value of them. So what A and B are is the values of x. So we want to know that value there, and as it goes upwards. So if we have a look at this, what do we know we can never have a square root of? So we can never have a root of a negative number. So that means if I had minus 7 as x, it will become 0, which is fine, but I can't have anything less than that. So that tells me A must be minus 7. And in order to find B, we need to go back to our values here, or our equation here, and our t is between 0 and pi over 2. So if we think about it, what is the maximum that cos 2t can be? So the maximum it can be is 1, the minimum is minus 1. So if we have 1 minus 8, that's the minus 7, which we already have. And if we had minus 1, minus 8 times minus 1 gives you plus 1. So we end up with b equaling 9. So you've got to think, what's the maximum and the minimum that trig identity can be? So that's going to be my values of a and b. And to find my range, well, I know the bottom side is 0. I need to find what my maximum y can be. Again, the maximum sine t is 1. So my maximum y will be 9. So I'm going to write 0 is less than or equal to f of x is less than or equal to 9. So hopefully that makes sense. If you've got any questions. Okay, so we're going to look at area under the curve, and we're going to look at this really strange example. It was in the old C4 papers, and it came up, and the year it came up, it did really confuse students and teachers. So I think it's a good integration to have seen. So if we've got e to the 2x sine x, what we're going to do is we're going to use integration by parts. So normally, when we do integration by parts, if there's ln x, that takes priority, and then there's an x to the n. Here, it doesn't seem obvious, so it doesn't actually matter in this case which one you take as u and which one you take as v dash. So I differentiate the u, and I integrate the sine x to give me minus cos x. So remember, sine differentiates to cos, which differentiates to minus sine, which differentiates to minus cos, which goes back to sine. So this is kind of the trick. We've got the integral of e to the 2x sine x dx equals uv, so minus e to the 2x cos x, minus the integral of v du dx. So that's going to give you minus 2 e to the 2x cos x dx. Now we've got a minus and a minus, so we're going to change that to a plus and delete that minus. Now what we've got to do is do this process again using this bit here. So we're going to do this bit here. So here our u is going to be 2e to the 2x. Again, it doesn't matter. That's going to be cos x. U dash will be 4e to the 2x. And cos integrates to sine. Right. So let's put everything in. Actually, let's do that bit separately first. So we've got 2e to the 2x cos x dx to give us uv. So we'll have our e to the 2x. So we'll have 2e to the 2x sine x minus the integral of these two together, so 4e to the 2x sine x dx. And this is where it comes in. You're going to put it all in one big long line. So you've got the integral of e to the 2x sine x dx equals minus e to the 2x cos x plus all of this. So that's replacing that. Sine x minus, and remember I can take a value outside of the integral sign. So hopefully now you can see you've got that on one side and you've got minus 4 of the same thing. So we can put them all together onto that side to give me 5 integral 2x sine x dx equals cos x plus 2e to the 2x sine x. Now I can divide by 5 and I end up with minus 1/5 e to the 2x cos x plus 2/5 e to the 2x sine x, and I'm going to put plus c there, and that gives me the integral of e to the 2x sine x, should be an x there, dx. And that's my answer. Now we've got to find the region bounded by the curve in the x-axis. We can see we're looking for when y equals 0 to find our limits. So e to the 2x sine x equals 0 will mean e to the 2x is 0, which is not valid. You can never have a negative indice. Or sine x equals 0. We can see in the answer there's a pi, which means we're going to be in radians. So inverse sine of 0, inverse sine of 0 is 0. And we know that the next time sine is 0, our rule is pi minus or 180 minus, so the next one is pi. And then all we do is we substitute the values in. So we've got minus 1/5 e to the 2 pi cos pi plus 2/5 e to the 2 pi sine pi. And from that we minus 2/5 e to the 0 sine 0. I've just put it the other way around here for some reason. E to the 0 cos 0. And if because we want it accurate, we have to do sort of in bits. We're going to get over here, we've got cos of pi gives you what? So that's like saying cos of 180, which is minus 1. So minus and a minus are going to make a positive. So we're going to get 1/5 e to the 2 pi. That should say sine pi. Right? Sine pi is the same as, so that's sine 180, which is 0. So that just disappears. So that zeros. Then we've got e to the 0, which is 1. We've got sine 0, which is 0. So that disappears. Then we've got a minus and a minus, which is going to make a plus. Cos of 0, which is, so when you've got cos of 0 is 1. So we're going to get e to the 0 is 1. So we're going to get minus 1/5, but it's minus minus, so it's going to become plus 1/5. And that is the same as what they wanted. So we're all good. And that is a very, it's an area under the curve, but okay, we've got a first order differential equation with partial fractions. Now here, they kind of hinted to you, they've told you to write it in partial fraction form in part A. So what I would always recommend, okay, so we've got a minus 5, a plus 3. We've used a, so maybe we use c over a minus 5 plus b over a plus 3. So we get c a plus 3, b a minus 5, when a equals 5, and all of this equals 1. When a equals 5, we get 8c equals 1, so c is an eighth. And when a equals minus 3, we're going to get minus 8b equals 1, so b equals minus an eighth. So we can then write it as, and I would just write it, I wouldn't try to put the 8 on the bottom. The way I'd represent that is, you're going to rewrite this, but I would have on top of the a minus 5, I'm just going to have an eighth, and on top of the a plus 3, I'm going to have minus an eighth. Okay. The depth of the water in the tank, A meters, is modelled by the differential equation, where T is the time in days from when the monitoring began. Now you're going to see this word, differential equation, right? And differential equation, sorry, there you go, in the question. And your brain is going to go separate variables. I'm going to put all the A's on one side and all the T's on the other side. And my dt has to be up and my dA has to be up. And they can't kind of exist without each other. We've been told to do this, so we want one side to look at this because it's going to help us. So if we do 1 over a minus 5, a plus 3, So I'm moving that down there, dA, and remember dA can't live without an integral sign, equals, we bring the dt up, the integral of 1 over 40 dt, minus 1 over 40. So to integrate what we have there, we're going to rewrite it as with our partial fractions. So we've got 1 over 8 a minus 5, and then plus minus 1 over 8 a plus 3 dA. Yeah, that's fine. And then that equals, and we can just integrate the other side straight away because it's just minus 1 over 40 minus 1 over 40t. So that's just with respect to t. So when we're integrating 1 over, we get ln. So it's 1 over 8 ln a minus 5 minus 1 over 8 ln a plus 3. And we've got to put plus c, and I'll just put it on that side for the moment. Right, in the question, it tells us the time taken for the depth of water in the tank to fall to 8, right, is what we're trying to find. Sorry, I didn't read the question. The initial, that's what I was looking for, was 13. And then we're going to have to solve it. All right, I was jumping ahead of us. So let's start with the beginning bit. We need to find our plus c using the fact that when t equals 0, a equals 8. 13. Okay, I'm obsessed with 8 today. Right, so 1/8 ln 13 minus 5 minus 1/8 ln 13 plus 3 equals t is 0, so that disappears, as that's going to give me c. So my c is going to come out as, there we go. So we're going to have 1/8 ln 8 minus 1/8 ln 16 equals c. Right, now what you can do is you can combine it all now, but what I tend to do is leave everything like that, stick it all back into the formula, and then I'm going to times everything by 8 to get rid of those 8, and then I'm going to combine my logs. Equals minus 1 over 40t plus ln 1/8 ln 8 minus 1/8 ln 16. So I'm going to times everything by 8, and I'm going to try sort my log, put all my logs on one side. So I'm going to get ln a minus 5, the 8's going to disappear. This is take away, so this is going to go on the bottom, a plus 3. I'm going to move this onto this side, and so that's going to become ln 16, which I can multiply by, multiply by, and then I'm dividing by the 8. So actually I'm just timesing that by 2, and I get minus 1 over 40t. So if the logs, opening out the logs confused you, do times 8 first, then put all the logs on one side. So you'll get 8 over 40 as well, which you can rewrite as 1 over 5. And if you, or 0.2, if you look at your answers, we seem to be going in the right direction. Okay, so this is the same as 8 over 0.2t. Okay, so you're timesing everything by 8, you're putting all the logs on one side. Now you want to get rid of the ln. The opposite of ln is e. So if we e both sides, you've got e to the minus 0.2t. And at this point here, you've got 6 out of the 7 marks. So don't spend hours with the manipulation. So all you're doing for this last bit is rearranging it to make a the subject of the formula. So I multiply up, and I'll get a lots of e 0.2t plus 3e to the minus 0.2t. I'm going to move the a's onto one side. So I'll get 2a minus a e to the minus 0.2t equals 10 plus 3e to the 0.2t. Take a outside the bracket, and hopefully you can see you will have your answer. Okay, next bit says, hence now we get to find out how long it takes it to fall to 8. So we're going to make this, and even if you didn't get that first bit for whatever reason, you can still do this bit, because you're going to make it equal to 8. Equals 8. All right, when I multiply that up, I'm going to have 8 times 3 to give me, so I've got 10 plus 3 e to the minus 0.2t equals 24 minus 8 lots of e to the minus 0.2t. Put them all on one side. Get 11 lots of e to the minus 0.2t equals 24 minus, so we're going to have 24 take away 10, so we're going to get 14. Okay, let's check we've done that right. So, oh, that should be a 2, not a 3. Right, 16. That's a bit better. Okay, so if you were staring at that wondering what I'd done, it's because I'd done something wrong. So that's going to give me 16 minus 10, so that's going to give me 6. Okay, and then you've got e to the minus 0t equals 6 over 11. To get rid of the e, you've got to ln it. So ln 6 over 11. And then you divide by minus 0.2, which is the same as multiplying by minus 5. And they want time, so you could find the time, but because they don't say anything, you could just leave it exact. Double check that gives you a positive number, which it will do because ln is negative. When it is, ln, if it's a fraction, is negative. Right, according to the model, the depth of the water will eventually fall to n. State the value of the constant n. Well, we just take our leading coefficients, which don't have any minuses, because as t gets bigger and bigger and bigger, e to the minus 0t tends to 0. So we're going to get, as we get bigger and bigger and bigger, the leading coefficients of 10 or 2 are what's left. So we end up with, according to the model, n equals 10 over 2, so 5. Okay, so I hope that was useful. Make sure you can do partial fractions. Okay, we're on the home stretch now, we're almost done. We've got the trapezium rule. Okay, so with the trapezium rule, we're going to have, from our formula book, we get given, let me see if I've got it, yeah. We get given this formula. So your first step is to identify your h. Now your h is always your difference in your x's. So h is 0.25. And then you want to identify your y naught. That's your first y, your yn, which is your second y, and you are going to stick it right down exactly as it's given in the formula book. So you've got the integral between 2 and 1. Your y dx equals 1/2 times h, which is 0.25. Okay, big squiggly brackets. Y naught, which is 8.32, plus yn 99.8, plus 2 lots of everything in the middle, 21.4, 40.6, 66.6, close squiggly brackets. And you can type it exactly like that into your calculator. They want it to 2 significant figures. You type that in and you'll get 46. So out of the 3 marks, 1 mark for identifying the h, 1 mark for that big long line, and there's only 1 mark for the actual solution. But you need to write it out. Okay, so there's the first bit, which is our trapezium rule. Part B, we're going to be using a substitution of u equals x squared. So let's rewrite the original equation. So we've got ln 2x squared dx, and we know the limits were between 2 and 1. Okay, so we start off with our u. The first step is du dx to give us 2x, and you're going to rearrange that to make dx the subject. So you've got du over 2x And we could say, well, we can see here that x is the same as the square root of u, or u to the power of a half. So this is the same as du over 2u to the half. Then you're going to do your limits. So you've got your x's and your u's. So x is 2, u is x squared, so that's going to be 4. That's 1 and 1, which agrees with what they have. And now you substitute. So we can do 4 and 1, 12. Instead of x squared, we've got u. ln. Instead of 2x squared, we've got 2u. And instead of dx, we've got du over 2u to the half. Okay, so we can see here that 2 is going to cancel and make that a 6. This u to the half is going to cancel and make this one u to the half. And if I rewrite that, I've got between 4 and 1, 6u to the half ln 2u du. And so I've shown that we've got the same thing. And now we want to integrate that. Now this time we can use by parts, and we know it's going to work out nicely and it's not that weird formula because we have an ln. So remember, ln always takes priority. So that is going to be your u and that is going to be your v dash. So let's get our by parts formula up again. So we've got our formula for integration by parts, which is at the bottom and is given to you on in your formula book. So we've got u, we're going to let u equal ln 2u. So it always takes priority as u. We don't know how to integrate it directly. And v dash is going to be 6u to the half. Right. So we've got our formula, we know where it is. We're going to use that formula. So we're going to differentiate the u. Now remember, when we differentiate ln, so this is weird because we've got u and u. So if we call this, okay, that's very annoying. I'm going to call this like a big U. So du, d small u. Right. So whenever we differentiate ln, whatever's in the bracket goes on the bottom. The differential of the bracket goes on the top. And in this case, because it's 2u, it just becomes 1 over u. And when we integrate, we add 1 to the power. So we're adding 1 to the power. So we've got 6u to the 3 over 2 divided by 3 over 2. And that's going to give us 6 times 2 divided by 3. So it's going to give you 4. 4u to the 3 over 2. Okay, so then we're going to stick our values in. And so that's going to be big U there times V. So we get 4u to the 3 over 2 ln 2u minus the integral of these two multiplied together times 1 over u du. Right? So that's going to cancel out nicely. So we get rid of, so if we do 3 over 2, and we're going to be minusing 1, so that's just going to give us 4u to the half there. So do that. And so the final integration, which we're going to stick values into, is going to be 4u 3 over 2 ln 2u minus, so add 1 to the power to make it 3 over 2, divide by 3 over 2, which is going to leave you with 4 over 9. And we want to stick our values in of 4 and 1. So we'll get sticking 4 in. We're going to have to do it in bits because it wants it exact. So we get 32 ln 8 minus 64 over 3 minus 4 ln 2 minus 8 thirds. Should be 3. And when you clean that out, you're going to end up with, they want it in terms of ln 2. Okay, so let's take this last bit and let's add in some space to do it. add a sheet and put that there. Okay, so we've got to the point where we've got 32 ln 8 minus 64 over 3 minus 4 ln 2 minus 8 over 3. And what we want to do is we want to make sure our answer is in that form. If you notice, we've got an ln 8 here, and they just want everything to be ln 2. So remember, 8 is the same as 2 cubed. So we've got 32 ln 2 cubed, and that 3 can come down. So we end up having 32 times 3, so 96 ln 2. And then we can do minus 64 over 3, minus minus, which makes a plus. So minus 64 plus 8, which gives you minus 56 over 3. And then we've also got minus 4 ln 2. So my final answer is going to be 92 ln 2 minus 56 over 3. So A equals 56 over 3. Minus 56 over 3, and B equals 92. So just always make it super. Okay, so this is from a recentish paper, or I think it might have been from the sample paper, I can't remember, but you may have already done it. But relative to a fixed origin, we've got points P, Q, and R, and Q lies 1/3 of the way from P to R. So we've got 1/3 and 2/3. And remember, a vector is represented from where it is, like from an origin. So that's going to represent a small p, that's going to be small q, and that's going to be small r. And we want to show that q equals 1/3. Okay, so we're going to find so let's say we're going to try find q. Right, so we're going from O to Q. So to go this is closed, the road is closed. We could go up here and across. So we can go from O to P plus P to Q. And what do we know about P to Q? Well, we know this is P. We know P to Q is 1/3 of P to R. That's Q. 1/3 of P to R, which is going from P to R, so it's minus P plus R. If we open out those brackets, we get minus 1/3 P plus 1/3 R. 1P minus 1/3 P gives us 2/3 P plus 1/3 R. We can take 1/3 outside the bracket and we have the answer.